In this lecture, we will be solving a problem on the design of squirrel cage rotor. The question is 11 kilowatt 3-phase 6-pole 50 Hz 220 volt star connected induction motor has 54 stator slots, each containing 9 conductors. Calculate the values of bar and end ring currents. The number of rotor bars is 64. The machine has an efficiency of 0.86 and a power factor of 0.85. The rotor MMF may be assumed as 85% of stator MMF. Also find the bar and the end ring sections if the current density is 5 ampere per millimeter square. So, certain data of a squirrel cage induction motor is given here, and we have to calculate the value of bar current and end ring current, and also the area of cross section of the rotor bar and the end ring. So first of all, we need to calculate the bar current and end ring current. So let us go through the equation. So bar current, we already know the equation for rotor bar current IB, which is equal to 0.85 into IS into 60S divided by SR. So this equation is obtained from the assumption that the rotor MMF is 85% of stator MMF. The condition given in the question is also the same. Rotor MMF may be assumed as 85% of the stator MMF. So we can use 0.85 here. So 0.85 into stator MMF, that is IS into 60S. So here 60S is the total number of conductors in the stator. TS is the number of stator turns per phase, and 6 into TS gives the total number of stator conductors. IS is the stator current per phase, and SR is the number of rotor slots. Okay. So in order to calculate the bar current, we need to know each of these parameters, IS, TS and SR. Okay. So I have already said that 6 TS is the total number of stator conductors. So either we need to know the value of TS or 6 TS, the total number of stator conductors. So here in this question, there are some data for calculating the total number of stator conductors. It is given that the stator is having 54 slots, and in each slots there are 9 conductors. So a total of 54 stator slots and 9 conductors per slot. So we can write total number of stator conductors, that is 6 into TS, is equal to 54 into 9. Total number of stator conductors into number of conductors in each slot. So that will be equal to 486. So next parameter is SR, which is nothing but the number of rotor slots, and we know that in a squirrel cage rotor, 1 bar is inserted in each of the slot. 1 bar per slot. So total number of rotor slots and total number of rotor bars will be equal. So number of rotor bars is given here, that is 64. So we can take the number of rotor slots equal to 64. So next we need the value of the stator current per phase, IS. So we can always calculate the current from the kVA rating. So here we know that in case of an induction motor, the electrical power is at the input side. So we have to calculate the current, the stator current. Stator is the input side, okay. So we have to calculate the stator current from the input volt ampere rating. Okay. So we have to calculate the stator current from the input volt ampere rating. So we know that power in volt ampere, that is apparent power, is equal to √3 into VL into IL. So from that we can write the current is equal to input power in volt ampere, or the apparent power divided by √3 into VL. Okay. Now input power in volt ampere. We need the input power in volt ampere. But what given here is the output kilowatt. 11 kilowatt is the output kilowatt rating. So we have to convert this kilowatt power at the output to input volt ampere. So for that, first of all, that kilowatt is converted to watt. So 11 kilowatt is equal to 11,000 watt. Now we have to convert it to volt ampere. Input volt ampere. So this output power has to be converted to input power, and output power in watt has to be converted to volt ampere. Okay. So for that, we can divide the output power in watt by efficiency and power factor. So output power divided by the efficiency, that is 0.86, gives the input power in watt. So output power 11,000 watt divided by the efficiency gives the input power in watt, divided by the power factor gives the input power in volt ampere. Okay, and that value divided by root 3 into VL will be the value of the stator current or the input current. So here we are considering root 3 into VL into IL. So this 40 ampere is the line value of stator current, and here it is given that the stator is star connected. So that means line value of stator current and phase value of stator current are the same. So we can substitute instead of this IS, that is stator current per phase, as 40 ampere. So substituting the values, we will get the answer, the bar current, as 258 ampere. Now we have to calculate the end-ring current, and the equation for end-ring current is SR into IB divided by pi P, number of rotor slots into the rotor bar current divided by pi into number of poles. So SR we have it as 64, IB, the calculated value of IB is 258 divided by pi into the number of poles is 6. So answer will be 883 amperes. So we got the value of bar current as well as the end-ring current. Now we have to calculate the area of cross-section of the rotor bar as well as the end-ring. So we know that area of cross-section can be calculated as current divided by current density. So area of the rotor bar is equal to rotor bar current divided by current density, that is 258 divided by 5. So current density, as we are substituting the current density, value of current density in ampere per millimeter square, so 5 ampere per millimeter square. So the resulting area will be in mm square, millimeter square. So we will get the area of the rotor bar as 51.6 mm square, and area of cross section of the end ring is end ring current divided by current density, that is 176.66 mm square.